Hello, everyone. Thank you very much for joining us again. Today, I have with me a special guest, Tagir. He's the author of a new book that will be published with many publications, 100 Java mistakes and how to avoid them. And I'm very curious today to find out more about what I can do wrong with Java, how to avoid them, of course, and how to use Java in a proper way. And thank you very much, Tagir, for being here with us today. I'm very eager to learn a lot a lot from you today.
Hello, and thank you for inviting me.
So you publish a new book and it's about Java and it's about mistakes, pitfalls that you can do. Tell us a bit more, which are like the most common pitfalls that a Java developer would do? Is this something that junior developers would be more likely to do, or it's something that you have seen in your experience also with senior developers?
Actually, I'm speaking about mistakes that probably every Java developer can make, regardless of the level. It's just depends on previous experience. Like probably you won't do some kind of mistake if you already stepped on it in your career. So of course it's less likely than senior developer will do this, but why stepping on mistake if you can read the book in advance and learn a little bit? So in this case, you probably have experience without actually breaking production or something like this.
So which are the most common mistakes that you've seen in the real world out there?
Well, if you are speaking about Java, probably nothing beats null pointer exception. I mean, forgetting to check for null before dereferencing, or probably storing null in the variable where null is not actually expected, which is, to my opinion, much more dangerous, because if you even check for null later, it will be much later, so probably it will be hard to debug.
I know that Java tried to cover a lot this null pointer exception stuff. First of all, by introducing the optionals in Java 8. And secondly, very recently, we have now an enhanced message that finally tells us exactly what is null in that exception, because previously you didn't even know that. Do you think these are enough to solve the null pointer exceptions problem, or should we like wait for some more, ask the community to implement something else that could help even better with the management of null pointers?
Well, in general, it's not enough, because optional is not like solution to all the problems. First of all, you cannot simply put optional everywhere, because it clutters your code, it makes it much harder to read. And in many existing APIs, null is already used, and they are not using optional, and they cannot like easily migrate. So people have different opinions on optional, and not everybody like to use them like everywhere. And in fact, I think that it should not be used everywhere, because optional, to my opinion, it's has quite limited semantics. Like it depicts the absence of the object, or something which is not found, and something which is absent. But people use null to depict many different things. For example, uninitialized value is null, unknown value is null, not found value is null, like incorrect value could be encoded as null, and everything depends on the context. So it's much better in many cases to use some like special value with special documentation. For example, if it's an enum, it's better to introduce additional constant which specifies like this is unspecified value or whatever. then you can document this constant, and it's much better than wrapping this enum into optional, of course. But it's not always possible because not always you can modify existing type. Sometimes it could be solved with sealed types. Sealed types were introduced in Java 17. So, for example, you have like a single implementation of some interface, and sometimes you store null in this variable. Then probably you can create this interface sealed, create another singleton or enum, and this value will be used to depict that the null value, what null value was used before. But in general, there are also different approaches. Some people use annotations like nullable, not null annotation. I'm speaking about them in the book, and they allow to somehow deal with nulls. Some people don't use nulls at all as much as possible. I heard that in Google, most of the code they write in Java are like null hostile, so they try to avoid nulls in all the APIs. But in general, I don't think that recent improvements in Java completely solve this problem. They make it easier to handle, but not solving completely.
Okay, super. So we still have to that's why we have newer versions, isn't it? So at some point we will have Java 21 in the future, and then 22, and so on and so forth. So maybe in the future we'll have even more tools that will help us.
Yes, actually there is a trailing drafts in Valhalla project. I don't know whether you have seen them. There is actually draft of nullable markers. So they will probably add special markers in type system to depict that this value could be null and this value cannot be null. The details are not ready yet, and probably it will be only for value types which are used in Valhalla. I don't know exactly, but in any case, it sounds like something big because we haven't seen anything like this in Java before.
Okay, sounds good. No, I didn't know about this enhancement, but that sounds really interesting. So I will take a look at Valhalla after this talk. And guys, you heard, so we have things related to null checks. So we have to take a look at this as well. Now, I was aware about Ember, about Valhalla, about Loom, and all the other projects. I didn't see this. It's a very interesting thing that I've learned today. What other thing do you see out there very oftenly misused in Java by developers aside to null pointers exceptions?
In fact, there are many things. At least 100 of them are covered in my book. Yes, there are like many individual problems. I speak quite a lot of about equals and comparison contracts because it's surprisingly easy to implement compare to incorrectly or use compare to incorrectly or implement equals incorrectly. So there are like a handful of mistakes.
Isn't that just right click insert in IntelliJ or stuff like that? I mean,
in many cases, yes, but there are some still some caveats with this approach. It's not always like you are happy with default implementation. You want to do something different, and sometimes, like for example, with Java records, you know that with Java records you don't need to write equals and hash code, and they are written automatically for you. So you can say, thanks God, I don't need to care about this anymore. But for example, if your record component is array, it will be compared by equals, but for array equals is just reference equality, so you will not have comparison of elements. And if you forget about this, your record will function incorrectly, so you will still have to override equals and write it. And sometimes problems are not with creating equals, but with using it. For example, one may think, I have two string builders. I want to check whether they have equal content. Why not to use string builder.equals? But it doesn't work because string builder doesn't define equals. So it will be simple reference equality, and you will not check the content actually using this. So there are some things like this. And I guess popular IDs, at least IntelliJ idea, don't generate compare to for you because it's probably not very simple task. Probably it's a good idea for enhancement, but if you want to write comparator or implement comparable, you are on your own. You have to write it somehow manually or using ChatGPT.
Nah, that's the new tool. Yeah. A lot of people make a lot of fuss now with ChatGPT.
Yes, there are also many problems in Java, for example, with collection mutability, because type system does not encode this, and you never know whether your collection will be mutable or not. So sometimes people like get collection from somewhere and try to add elements or something like this. I also covered this in the book.
And I'm not sure if you covered it or you will cover it, but I saw one mistakes repeatedly throughout the years. People using double and float for additions, multiplications, and other operations with decimals. And I know that this is not a good practice because it doesn't guarantee that it will add up all the decimals correctly, is it?
You mean possible loss of precision in this case?
Exactly. Mm-hmm.
Yes, I'm speaking about it, not very much, but something in chapter 4 is devoted to problems with floating point numbers. And also I have quite a big mistake about numeric overflow because it's really what happens always, and Java will not actually tell you if your like result of multiplication of integer multiplication silently overflows. You will get no compilation error, no exception, nothing. You will just get totally incorrect result. Yes.
Yeah, and that could be such a pain in a production environment, isn't it? Because you don't know where the value.
Yes, and I actually heard many cases about this, not only in Java, because actually overflow affects probably almost all mainstream programming languages. For example, I guess there was an interesting story on NASDAQ stock exchange when price of one stock exceeded like 400,000. It doesn't look like overflow, but they normalized all the prices at 100th part of 1 cent. So every price in dollars was multiplied by 10,000. And at some point, they probably thought that one stock can never cost more than $400,000. But this happened. And something totally wrong happened, and they had to stop like trading of this particular stock because the price was too much and the system simply overflowed.
I didn't know actually about the NASDAQ problem, but I know another funny story. I'm not sure if it's Java, what was behind the scenes, but some years ago, if you remember Gangnam Style, that Korean video.
Yes, yes.
It was the first one to actually have over a billion likes on YouTube or something like that, and then it overflowed. So and YouTube had to correct that. I'm not sure if it was Java behind the scenes, but it's a funny example of an overflow.
Yes, sure. And I'm actually saying this in my book. Like for now, you may probably think that like 2 billion is a ridiculous number. You will never reach it. But when your business grows, probably you will have like more revenue, or probably you will have more downloads or more whatever, and numbers will suddenly be much bigger than you expected.
One of the chapters that I see in your book is referring to unit tests. What do you plan to tell us about unit tests?
Yes, the last chapter is about unit tests, and one may say, okay, mistakes in Java are not a big problem. Just write unit tests and you will catch all your mistakes. But this is not always. This doesn't solve all problems as well, because unit tests may also contain mistakes, and there are like a bunch of cases when unit test actually tests nothing. For example, I saw actually when people wanted to type assert true for a Boolean variable, but instead of that, they type assert not null for the same Boolean variable. In this case, Boolean variable gets silently boxed, and it will be always not null. So this assert will be always true, and it will never fail. So your test will be testing nothing. And you may never know this because, okay, tests pass, everything is green, everything is great, but test is actually useless. And I cover some cases like this in this chapter.
Yeah, I'm amused that actually about unit tests when developers write, like they have tests and they have 100% coverage. I know that's very that's not very often, but they forget about the possibility of reversing the lines, you know. So you have 100% coverage, but actually if you reverse the line, the test doesn't work anymore. The application doesn't work anymore. The test still works because you don't test that case actually, but it's quite a twitch that many developers, I think, forget about.
Yes, in fact, in several places of my book, I actually say that, okay, we have an example of erroneous code. This doesn't work as expected, but you can write several simple unit tests, and you will have 100% coverage of this function, and all the tests will pass, but still the code is incorrect. So in fact, yes, 100% of coverage doesn't guarantee that your code is correct.
Yeah, so it's basically, it's funny because you don't even have usually 100% of the coverage, isn't it?
Yes,
so even
yes,
with 100%
exactly.
of coverage, it's not guaranteed that now you have everything in place and out of bugs.
That's actually what I'm speaking quite much in the first chapter, because, well, there are many approaches to manage code quality. Like you may have peer review, for example, you may have static analysis, you may have some kind of dynamic analysis, you may have unit tests, you may have assertions. But in fact, no single approach can solve all your problems. So to make sure that your program has, well, not bug-free, but has not so many bugs, you have to combine approaches. You should use everything. You should write unit tests, you should use static analysis, you should use peer review, and so on.
By the way, do you often encounter memory mistakes like stack overflow or out of memory errors in Java apps? Do you consider?
Well, as an author of popular IDE, I encounter this quite often. Stack Overflow is really a big problem for IDEs because you know that IDEs always work with parse trees. You have your program in your editor and you need to reason somehow about this program to find mistakes, to propose completion, and so on. So you have to walk through parse trees, and in some rare cases, parse trees could be really deep, and you may have Stack Overflow error. We actually you may probably try this create nested lambda parenthesis arrow parenthesis arrow and repeat this 2000 of times in the editor. Probably something will go wrong because editor may not be ready for such things. And we have some special means inside IntelliJ IDEA, some recursion guards to prevent Stack Overflow error and try to report the problem in more nice way, or try to recover from possible Stack Overflow or whatever. And out of memory, actually happens, I don't cover it in my book because I don't see much I can say about this. Like, well, it could be probably a separate book, like optimizing memory usage in Java, but it's not like correctness mistake. Sometimes, well, people just have a lot of data to process, and you just simply have not enough memory.
Okay, there's only one more question, and we can conclude the discussion. Besides reading your book, which are some ways in which a developer might avoid these problems, or discover them easily or solve them? Are there tools that we can use upfront to make sure that we at least minimize the chance of making such mistakes?
In general, my book mostly focused on static analysis, so it actually promotes static analysis tools, and we have very nice Java static analyzer built in IntelliJ IDEA. So if you use IntelliJ IDEA, you don't have to install anything in addition. You will just have additional warnings in the editor. So what you have to do is to pay attention to those warnings, and actually they may catch I think more than half errors covered in the book, but not in all the cases. And in most of the chapters, in most of the sections, I have this static analysis sidebar where I see how static analyzer reports or doesn't report this problem, because sometimes like it reports it if it looks simple. But for example, if you extract something to a variable or extract something to separate method, it doesn't see the problem anymore. So it's still better that you actually know that this problem exists, and because if your code is not very straightforward, static analyzer may fail. But in general, this tool is really helpful, and you can actually learn from static analyzer, because like if you make a mistake, it will highlight it, and you read the description and you understand, oh, this way I should not write the program, and you can learn something new. Of course, IntelliJ IDEA is not the only static analyzer. I can recommend Sonar. They have Sonar Lint for Java, and it's pretty good. There are other tools like PVS Studio, like Spotbugs, Error Prone from Google, and so on. So just use at least one of static analyzers, either in IDE, either on your continuous integration server, preferably both, in both places, but you should use at least something.
Cool. Thank you very much, Tagir. So, guys, we've discussed about a few of the issues, but of course, we can't discuss 100 issues in 20 minutes. So my recommendation for you is take Tagir's book, 100 Java Mistakes and How to Avoid Them. It's now in early access, already available, and a few chapters are published, and it will be full this fall. So if you want to know how to avoid mistakes, yes, you can use tools like your IDE or like Sonar in your pipeline, in your continuous integration, but you still need to know things up front, because that's how experts do. And to do that, you can find them from books, and one of the books is Tagir's book. So why not taking this chance and finding out yourself? Thank you very much, Tagir, for this discussion, for this interesting discussion. And guys, thank you very much for joining us, and hope to see you later in other videos. Waving goodbye.
Thank you. Goodbye.